When dealing with an 8-wire, 4-circuit configuration in a workstation, where you have 4 hots, 2 neutrals, and 2 grounds, the correct method is to tie all 4 individual 20-amp circuit breakers together. There are several reasons for this recommendation, primarily related to safety, code compliance, and the proper functioning of multi-wire branch circuits. A multi-wire branch circuit, often abbreviated as MWBC, is a circuit that consists of 2 or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and which is connected to the neutral or grounded conductor of the system. Multi-wire branch circuits are commonly used to supply power to multiple receptacles or devices in commercial and residential settings. The key advantage of a multi-wire branch circuit is that it can provide multiple circuits using only one neutral conductor, thereby reducing the amount of wiring required and saving on materials and labor costs. However, multi-wire branch circuits must be installed and used correctly to ensure safety and to prevent electrical hazards. The reason for tying the circuit breakers together is to ensure that if any one of the circuits experiences an overcurrent or short circuit, all the circuits are disconnected simultaneously. This is typically achieved by using a listed handle tie or a multi-pole circuit breaker. The National Electrical Code (NEC) specifically addresses this requirement to prevent a situation where one circuit is inadvertently left energized while work is being performed on another circuit sharing the same neutral. If you were to use a 3-pole breaker for 3 circuits sharing a neutral and a single-pole breaker for the dedicated circuit, you would not have the same level of protection. The single-pole breaker could trip independently, leaving the other 3 circuits energized, or vice versa. This could create a dangerous situation for anyone working on the electrical system, as they might assume the entire circuit is de-energized when it is not. Furthermore, using independent breakers does not comply with the NEC requirements for multi-wire branch circuits. The NEC mandates that all conductors of a multi-wire branch circuit must be disconnected simultaneously by the circuit breaker. This is to prevent the neutral conductor from becoming overloaded. In a multi-wire branch circuit, the neutral conductor carries only the unbalanced current, which is the difference between the current flowing on each of the hot conductors. However, if one of the hot conductors is disconnected while the others remain energized, the neutral conductor can potentially carry the full current of the energized circuits. This can cause the neutral conductor to overheat and potentially start a fire. Tying all 4 20-amp circuit breakers together ensures that all circuits are disconnected simultaneously, preventing the possibility of an overloaded neutral conductor. This is achieved by using a listed handle tie, which mechanically connects the handles of the individual circuit breakers, or by using a multi-pole circuit breaker, which is a single device that contains multiple breakers in one housing. Both of these methods ensure that all circuits are disconnected simultaneously when any one of the breakers trips. Using individual single-pole breakers, even if they are adjacent to each other, does not provide the same level of protection. There is no guarantee that all of the breakers will trip simultaneously, especially in the event of a fault on one of the circuits. This is why the NEC requires that all conductors of a multi-wire branch circuit be disconnected simultaneously by the circuit breaker. It is important to note that the NEC is the primary standard for electrical safety in the United States. It is a comprehensive set of rules and regulations that are designed to protect people and property from electrical hazards. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. In addition to the NEC requirements, there may also be local electrical codes that apply. These codes may be more stringent than the NEC requirements, and it is important to comply with both the NEC and local codes. When installing or modifying electrical wiring, it is always best to consult with a qualified electrician. A qualified electrician will be familiar with the NEC and local codes, and they will be able to ensure that the wiring is installed safely and correctly. In the specific scenario described, where the workstation has an 8-wire, 4-circuit configuration with 4 hots, 2 neutrals, and 2 grounds, tying all 4 20-amp circuit breakers together is the recommended approach. This ensures safety, code compliance, and the proper functioning of the multi-wire branch circuits. It prevents the possibility of an overloaded neutral conductor and ensures that all circuits are disconnected simultaneously in the event of an overcurrent or short circuit. If there are any doubts or concerns about the proper way to wire the workstation, it is always best to consult with a qualified electrician. They will be able to assess the situation and provide guidance on the best way to proceed. Here is a further breakdown of why tying the breakers together is essential. Firstly, consider the shared neutral. In a multi-wire branch circuit, multiple hot wires share a single neutral wire. If the breakers are not tied together and one circuit experiences a fault, only that individual breaker might trip. The other circuit sharing the neutral could remain energized. This can lead to an imbalance in the neutral current. If the load on the remaining energized circuits is high, the neutral wire can become overloaded, potentially causing it to overheat and create a fire hazard. By tying the breakers together, a fault on any one circuit will trip all the breakers, immediately de-energizing all the hot wires sharing the neutral. Secondly, safety is paramount. The electrical work can be dangerous, and it is crucial to ensure that all circuits are properly de-energized before any work is performed. If the breakers are not tied together, it is possible for someone to mistakenly assume that a circuit is de-energized when it is not. This could lead to electric shock or electrocution. Tying the breakers together ensures that all related circuits are de-energized simultaneously, reducing the risk of accidental contact with live wires. Thirdly, the NEC mandates it. The National Electrical Code, which serves as the standard for safe electrical installations, requires that multi-wire branch circuits be equipped with a means to simultaneously disconnect all ungrounded conductors at the point where the branch circuit originates. This requirement is typically met by using a multi-pole circuit breaker or individual single-pole breakers with a listed handle tie. The handle tie mechanically connects the handles of the individual breakers so that they trip together. Fourthly, consider future modifications. If the workstation is ever modified or reconfigured in the future, having the breakers tied together will simplify the process and ensure that the multi-wire branch circuit remains properly protected. It will also prevent someone from inadvertently disconnecting only one of the circuits sharing the neutral, which could create a hazardous situation. Fifthly, proper labeling is important. In addition to tying the breakers together, it is also important to properly label the circuit breaker panel to indicate that the circuits are part of a multi-wire branch circuit. This will help prevent confusion in the future and ensure that anyone working on the electrical system is aware of the configuration. The labeling should clearly identify all of the circuits that share the same neutral and should indicate that all of the breakers must be turned off before any work is performed on any of the circuits. Sixthly, ground fault protection. While tying the breakers together protects against overcurrents and short circuits, it does not provide ground fault protection. Ground fault protection is designed to detect and interrupt low-level ground faults, which can be difficult to detect with standard circuit breakers. If ground fault protection is required for the workstation, a ground fault circuit interrupter (GFCI) breaker should be used. A GFCI breaker is a special type of circuit breaker that is designed to trip when it detects a ground fault. GFCI breakers are typically required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Seventhly, arc fault protection. Arc fault protection is another type of protection that is designed to prevent electrical fires. Arc faults are caused by unintentional electrical arcs, which can generate a lot of heat and can ignite nearby combustible materials. Arc fault circuit interrupters of size are special types of circuit breakers that are designed to trip when they detect an arc fault. A size are typically required in bedrooms and other areas where people sleep. Eighthly, consider voltage drop. Voltage drop is a decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail. To minimize voltage drop, it is important to use the correct size conductor for the length of the circuit. The NEC provides tables that can be used to determine the correct size conductor for a given application. Ninthly, conductor ampacity. Conductor ampacity is the maximum amount of current that a conductor can carry safely without overheating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The NEC provides tables that can be used to determine the ampacity of a conductor. It is important to select conductors with sufficient opacity for the load they will be carrying. Tenthly, proper grounding is essential. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and energize the circuit. All electrical equipment should be properly grounded in accordance with the NEC requirements. The grounding conductor should be sized according to the NEC tables and should be securely connected to the equipment grounding terminal. In summary, when dealing with an 8-wire, 4-circuit configuration in a workstation, tying all 4 20-amp circuit breakers together is the recommended approach. This ensures safety, code compliance, and the proper functioning of the multi-wire branch circuits. It is important to follow all applicable NEC requirements and local codes when installing or modifying electrical wiring. If there are any doubts or concerns about the proper way to wire the workstation, it is always best to consult with a qualified electrician. They will be able to assess the situation and provide guidance on the best way to proceed. This approach provides a safer and code-compliant electrical setup for the workstation, minimizing the risk of electrical hazards and ensuring the proper operation of the circuits. Remember that working with electricity can be dangerous. Always prioritize safety and consult with a qualified electrician if you are unsure about any aspect of the electrical installation. By following these guidelines, you can ensure that the workstation is wired safely and correctly. Tying the circuit breakers together is not just a suggestion, it is a critical safety measure that protects both people and property. Always adhere to the NEC and local codes, and never compromise on safety when working with electricity.